Hello there. We start off with a new chapter, which is circles, and today is the first class. So in this class we are going to discuss equation of circle. Now, like equation of straight line, there are different forms of equation of straight line. Similarly, there are different forms of equation of circle. So we are going to take few of those forms and we are going to discuss in this class, and rest of the problems or rest of the forms we are going to take up in the next class. So let us start. So before we go into the equation of circle, so let us first understand what is a circle. So a circle is basically defined by the locus of a moving point. Now, what is the meaning of the word locus, which you have already done in your class 10? Locus means a path. So the locus of a moving point, which is at a fixed distance from a fixed point, is called a circle, right? So the thing looks something like this. So there is a moving point which is moving in the plane, and there is a fixed point to which this moving point is equidistant all the time. So then whatever the path which is defined by the moving point, that path is called the circle, right? So the fixed point is called the center of the circle, and the fixed distance is called the radius of the circle. Fine. Now let us move to the equation of circle. So basically we are actually talking about, or we are actually dealing with, the concept of coordinate geometry. Now what does coordinate geometry do? It turns any geometrical concept into algebraic concept. So geometrical concept means any shape, any figure, and algebraic concept means in the form of equations. So it turns any geometrical shape or figure into equations. So we have already studied straight lines, so we know how to represent a straight line in the form of equations. So similarly, today we are going to learn how to represent a circle in the form of equations. So the first type that which we are going to talk about is where we know the center of the circle and we know the radius of the circle. So if these two data is given, then how to establish the equation of a circle. So let x comma y be any point on the circle. I can take any arbitrary point as x comma y, and then the distance of the point x comma y from origin is r, because obviously r is the radius. So if I take any point on the circle, so from the center to that point, the distance is always going to be r. So the situation looks something like this. I hope it is pretty familiar to you. Now if I drop a perpendicular from that point on the x-axis, so you can see the perpendicular distance, that is your y, and the distance from the origin to the foot of the perpendicular, that is your x. So it completes a right angle triangle. So therefore I can write x square plus y square, which is equals to r square. So this is called the standard form or the simplest form of equation of a circle. Now obviously in this case you have to remember that the center of the circle is at origin. Fine. Now let us move to the next form. Now instead of the center being at origin, if the center is at some arbitrary point h comma k, and the radius is given to be r. So we are given these two information, that is the coordinate of the center and the radius of the circle. So what happens in this case? Same thing. So let us take a point x comma y on the circle. So the distance from h comma k to x comma y, that is the center to that point, will be r, right? Now, if we just extend the line and we construct the right angle triangle as we did in the previous case it was pretty trivial, but in this case we have to understand where we are trying to draw the right angle triangle. So after completing, we have x minus h whole square plus y minus k whole square equals to r square. So therefore, the equation of the circle when the center is at h comma k and the radius is given to be r, then the equation is given by x minus h whole square plus y minus k whole square equals to r square. So this is called the central form of the circle. Now if you just look into it, that central form is the more generalized form than the standard form, because if the center is at origin, then h and k will be replaced by 0 and 0, so you get back your standard form. Fine. Next, let us move to the third type of equation. Now in the third type of equation, what are the things given? I am given the endpoints of a diameter. Endpoints of a diameter means any diameter it be, doesn't matter which diameter you take. If I am given the endpoints of the diameter, so let one be x1 y1, the other be x2 y2, then and let p x comma y be any point on the circle. So what happens? This is how the thing looks like. So a and b are the coordinates of the endpoints of the diameter, and p is any point on the circle. Now we know that there is a very popular theorem of circle that angle in a semicircle is right angle. That means if I have a diameter and I join the endpoints of a diameter to any point on the circle, then the angle made by that point is always a right angle or 90 degree. So that means AP and BP, they are perpendicular to each other, right? So therefore the slope of AP times slope of BP should be -1. So let us first find what is slope of AP and what is slope of BP, or you can call it PA and PB. So the slope of PA and PB, as they are perpendicular, their product must be -1. So therefore I can write y minus y1 by x minus x1 times y minus y2 by x minus x2, that is equals to -1. So now just doing some side transposing and then cross multiplication and then side transposing, then we get x minus x1 times x minus x2 plus y minus y1 times y minus y2 is 0. So this is called the diameter form or diametric form of a circle. So that is, if I am given the two endpoints of the diameter of any circle, then I can find the equation of the circle with the help of this formula. So now it is not much necessary for you to remember how the formula comes up. You can just remember the formula itself, but it is always good to know the how. You should always have the answer to the question how or why, because in that case you will be having a better understanding of the concept. Now let us move to problems. The first problem, simple one. Find the equation of the circle whose center is at origin and the radius is 5 units. So basically it is the question which is addressing the standard form of the circle. You are given the center at origin and you are also told what is the radius. So therefore it will be straightforward, x square plus y square equals to r square, that is 5 square, and hence the equation becomes x square plus y square equals to 25. So we are just going to leave our answer there. Number 2. Find the equation of the circle whose center is at 1, 1 and the radius is √2. So here in this case we have to make use of the center form. Now in the center form, that is I have to write the equation of the circle So it is x minus h whole square plus y minus k whole square equals to r square. So in this case it is x minus 1 whole square plus y minus 1 whole square equals to root 2 square. So if you just solve, that gives you x minus 1 whole square plus y minus 1 whole square is equals to 2. You can leave the answer here itself, but you can just go on solving further by breaking the whole squares and writing it. You get x square plus y square minus 2x minus 2y equals to 0. Fine. Number 3. Number 3, write the equation of a circle whose center is 8 comma minus 6 and which passes through 5 comma minus 2. So you see it is given that the center is mentioned and a point on the circle is mentioned, but you are not told anything about the radius. Now obviously it is needless to say that how to find the radius. If you just find the distance from the center to that point, that gives you the radius. Now, as I already know that the center is at 8 comma minus 6, so therefore I know the equation of the circle has to be x minus 8 whole square plus y plus 6 whole square equals to some r square, where r is the radius. So radius is the only thing which I don't know, so let me just find out. So as the circle passes through 5 comma minus 2, I can put that 5 comma minus 2 into the equation and solve. So after solving I get r square as 5 square, and therefore equation of the circle is x minus 8 whole square plus y plus 6 whole square equals to 5 square. So I just solved it in a different way. Also you could have done what? You could have found the distance between the 2 points, that would have also given you the radius. So I just shown you a different way, a different thought process, because this thought process may be useful in different other sums or sums with a little bit of higher difficulty. So just simplify it. You get x square plus y square minus 16x plus 12y plus 75 equals to 0. So just give it a check if I have done the correct calculation. I have done it in a hurry, so there may be some mistake. I hope not. Still. Number 4. Find the equation of a circle which has minus 2 comma 3 and 0 comma minus 1 as opposite ends of a diameter. So here you need to work with the diametric form. So in this case, I know equation of the circle in the diametric form is x minus x1, x minus x2 plus y minus y1, y minus y2 equals to 0. So all the data are given. You just need to put the values, calculate, and you get the answer. So therefore x minus 2 into x minus 0 plus y minus 3 into y plus 1 is equals to 0. Do your calculation, you get x square plus y square plus 2x minus 2y minus 3 equals to 0. So this is your final answer. Sorry for the disturbances in the background. As I told you, I am not at my usual place, so there can be some background noises coming. Now let us move to example number 5. In this question you have find the equation of a circle whose center is the point of intersection of the lines 2x plus y equals to 4 and x minus y equals to 5 and passes through the origin. So here you are neither given the center nor given the radius, but you are given that the center is intersection of the lines, intersection of two lines. So obviously by solving the two lines simultaneously I'll get the center, and also it is told that it is passing through origin. So I know one point on the circle. So if I find the distance between the point and the center, which is the point of intersection, then I get the radius. So basically always remember that to find the equation of a circle, either I must have the center and the radius given or the endpoints of diameter given. Now obviously these are not the only criteria, there are other criteria as well. So you can be given other different parameters from which you can find the equation. So we will be dealing with that in the next class. So for this class and whatever the idea we discussed, so let us try finding out the equation of the circle using all those ideas. So if you solve 2x plus y equals to 4 and x minus y equals to 5 simultaneously, you get the point 3 comma minus 2, which I am not doing because I hope you can solve two linear equations simultaneously. So now all I need to do, I need to find the equation of the circle. So again, if the center is 3 comma minus 2, I know the equation of the circle has to be in the of the form x minus 3 whole square plus y plus 2 whole square equals to r square, where r is the radius, which I don't know. And again, it is told that origin is one of the points on the circle, so just put it, solve it, I get r square as 13, and so therefore r is actually root over of 13, but I don't need that. R square is 13 given, so therefore the equation of the circle becomes x minus 3 whole square plus y plus 2 whole square equals to 13. Fine. And if you just solve it, you get x square plus y square minus 6x plus 4y equals to 0. Number 6. Find the equation of the circle which touch both the axes and touch the line x equals to 2a. Now let us first understand what is the meaning of a circle touching both the axes. So when a circle touch both the axes, whatever the point it touches, always remember that as the radii in any case are equal, so therefore the coordinate of the center has to be the same. It has to be a duplet. Duplet means the x coordinate and y coordinate has to be same. So when any circle touching of radius, say 1 unit, touching both the axes, then the center has to be 1 comma 1. If the radius is of 2 units, then the center has to be at 2 comma 2, and so on. Fine. Now here I don't know where the center is, but it is also telling us that it touches the line x equals to 2a. Now remember, x equals to 2a is basically a line which is parallel to y axis. So therefore x equal to 2a has to be on one side of the circle and the y axis has to be on the other side of the circle, right? So let me just show you the next figure. The figure is something like this. X equals to 2a is the line which is on the right hand side of the circle, and y axis has to be on the left hand side of the circle. Now obviously considering that 2a is positive. Now if 2a is negative, it could have given you a different set of equation. But the thing that you need to understand that there are two different circles which satisfy this criteria. That is, it touches both the axis, yes, and also it touches the line x equals to 2a. So therefore what do we have? We have the center of the circle either at a comma a or at a comma minus a. So therefore the equation of the circle has to become x minus a whole square plus y plus minus a whole square. Plus minus just because it is either in the first quadrant or in the fourth quadrant. And a square means obviously the radius is a, so therefore on the right hand side I have a square. So if I go on solving, I have x square plus y square minus 2ax plus minus 2ay plus a square equals to 0. Now if x equals to 2a would have been negative, that is if I would have had the line x equals to minus 2a, then it would have been just the opposite. It would have been on the other side, right? Now the last question, number 7. Now if you don't understand this question, please do get it clarified. I'll just explain it to you once more, but I am sure I have managed to explain it the best I could. Okay, now number 7. Find the equation of circle which touch the y-axis at a distance of 4 units from the origin and cut off an intercept of 6 units along the positive direction of x-axis. Now in case of straight line, if you remember the concept of intercept means whatever the point on any axis the straight line intersects, that point, that distance from the origin is called intercept. But in case of circle, the idea is a little bit different. The idea is something like this: if a circle intersect, whenever it is intersecting any straight line, it has to intersect at two different points, because we know that if it just touches at one point, then it becomes a tangent. But whenever I am talking about intercept, the line has to intersect the circle, and whenever a line intersects a circle, it intersects at two different points. So therefore the intercept, the concept of intercept in case of circle means CD. In the figure, CD is the intercept, that is the distance between the 2 points of intersection of the circle with the axis. If it is x-axis, then it will be on the x-axis. If it is y-axis, it will be on the y-axis. So this is the figure of the problem given. See, it is told that the circle is touching y-axis at a distance 4 units from the origin. So therefore, obviously, the distance 4 units from the origin is at 0, 4. Now you may ask that it could have been 0, -4 as well. Yes, but of course it is not told that it is 4 units above origin or below origin. So we are just going to consider it positive for the matter of fact. You could have considered it negative and you could have got just a different answer. Different answer will be just a negative in the value of y. That will be only the difference. Now CD is the intercept, which is given to be 6 units, right? Now let us drop a perpendicular from the center on the chord CD. Now remember, CD is the intercept made by the circle on the axis, but according to the property of circle, CD is also a chord of the circle. So now if I am dropping the perpendicular from the center to the chord, remember there is again another popular theorem which suggests that the perpendicular from the center bisects the chord, right? So therefore CM, the length CM is 3 units. I hope that is clear. Now remember this, CM is 3 units, RM, which is same as OA, is 4 units, right? So let me just show you the steps. Let me just take you through the steps, right? So till this much, that all I have said. So RM is 4 units. Now you can see CRM is forming a right angle triangle, so therefore from there I can find the value of CR or RC, which is basically 5. Now if RC is 5, then AR is also 5, because it's a circle. CR or AR, they are radii, so they have to be of same length, so therefore AR is also 5. So from there I can make the idea of what is the coordinate of the circle. So the coordinate of the circle becomes 5, 4, because you see AR is 5, so therefore the x coordinate is 5, and RM is 4, so therefore the y coordinate is 4. So therefore the coordinate of the center becomes 5, 4, right? And also the radius, that is RA or RC, whatever it is, but we have got that to be 5 units. So therefore the radius is 5 units. So that is basically all I need to know to find the equation of a circle. So I got the coordinate of the center, I got the radius as well. So therefore the equation of the circle becomes x minus 5 whole square plus y minus 4 whole square equals to 5 square. So now you can see very clearly, if I would have taken it on the other side, I could have got x plus minus 5 whole square plus y plus minus 4 whole square equals to 5 square, right? So that is more general. So you actually get 4 different circles basically, but I have just shown you one. You can definitely try finding the other 3. So just if you expand the squares, your answer is x square plus y square minus 10x minus 8y plus 16 equals to 0, right? So you have the whole week, as I am not taking the class, so please go through it and If you have any doubt, do get it clarified. Thank you.